Lesson 3.2, polynomial functions and their graphs. So we've already talked about most of these slides on Friday, but I'll go over it quickly. You've got your leading coefficient of 3 here, the degree of 5. Your constant is the constant without, it's the number without the variable, your coefficients, and then your leading term. Your leading term can tell you the behavior of your graph, and that's what we talked most about on Friday. The graph of a polynomial function is continuous. There are no holes, breaks, holes, or gaps, turns. The leading coefficient test will tell you. So here's what I do. Instead of trying to remember this, because this can be a little confusing, I think about what is my graph doing whenever it's y equals x squared, or f of x equals x squared, or f of x equals x cubed. If I can remember those two, then that will tell me what it does on the rest for the beginning and ending behavior of the graph. If it's squared and the leading coefficient is positive, it's going like this. Both the beginning and ending behavior, they both rise. That rise to the left and rise to the right. If the leading coefficient is negative and the exponent is squared or an even exponent, it falls to the left and falls to the right. If it's odd, I think of what is that parent function of f of x equals x cubed. Well, it falls to the left and rises to the right if the leading coefficient is positive. If the leading coefficient is negative, then that flips and it rises to the left and falls to the right. So if you can remember that, and one other little thing that we'll talk about here in a minute, it'll help you to be able to figure out what that graph should look like, to be able to sketch the graph. So if n is equal to the degree of the function, a polynomial function has at most n real zeros. And remember, we talked about what zeros are. That's where the graph crosses the x-axis. So if it has a degree of 3, then it should at most cross 3 times. And then it should have n minus 1 turns. So if it's a degree of 3, then it would have how many turns? 2. Even and odd multiplicity. So let's look here at the, well, I guess what I need to do really to explain this better is give you factors. Let's just, so did everybody get this written down? And we'll apply this whenever we work a problem in a minute instead of me just making up stuff and taking extra time. I think. Hold on just a second. Let me go through and see. Okay, yeah, when we work the problems, we'll just refer back to this graph here to see what to do. All right, sketch the graph of the function by transforming the graph of an appropriate function of the form of y equals x to the n form from figure 1. So we'll turn to figure 1, which is in your book, but you probably already know, it's on page 255. If you can at least look over that real quick to see y equals x squared, y equals x cubed. You already know what those three look like, but y equals x to the 4th and x to the 5th, it just flattens out that curve a little bit to give you an idea of what's going on when we graph these. It says indicate all x and y intercepts on each graph. Okay, so remember, if this said x squared minus 16, we would know exactly how to graph that, wouldn't we? Where's that vertex at? Negative 16. And then I just put that parabola, right? But it also says indicate all x and y intercepts. So let's do that. Let's find out what those are. Do that, right, to find the intercepts. When I plug 0 in for x, what do I get for p of x or y, however you want to look at that? Negative 16. So that's a point on my graph. That's the vertex. If I put 0 in for y, have to solve that for x. So that 16 is equal to x to the 4th. And then how do I get rid of x to the 4th? Take the 4th root, so it's plus or minus the 4th root of 16. Yes, 4th root of 16. So that would be x is equal to plus or minus 2. So this, we'll let the y-axis be, well, the reason I have this instead of a regular graph, we're just going to say that this is negative 16. And then we'll let this be negative 2, and this be positive 2. Those points on the graph. What is the behavior? And if you can look on page 255, you can see the behavior of the curve whenever it's to the 4th power. So what is that, a little bit flatter there? It's hard to show it on this, really. But that's supposed to be a little bit flatter there at the curve. So I have the y-intercept and the 2 x-intercepts. Okay, on the next one, where is the vertex? Oh, I'm sorry, I copied this down wrong. I forgot to change it. I think this is a plus in the book. Put a plus there. So where is the vertex? To the right 5 or to the left 5, up 5, down 5? To the left 5? Right there? And is it flipped up or flipped down? Down. Flipped down, but I'm not going to graph it yet because I want to find my x and y intercepts. Well, we kind of know that already on the x-intercept. So if I plug 0 in for x, is it negative 625?
Yep.
Okay. If I plug 0 in for y, or p of x, what happens if I take the 4th root of both sides? Does it go away?
Yeah.
What's the 4th root of 0?
0.
0. Shouldn't I get negative 5? Because that's an x-intercept. Let me move this over so I have room to graph it. So let's pretend that negative 625 is here. Right? Yes.
Why did you get rid of the negative in the second step?
If you divide both sides by negative 1,
Oh, okay.
it goes away. Okay, 2 more. Where's the vertex on that one?
So I'll say like
Up 5.
So should it be here?
Yes.
On x and y intercepts? I put 0 in for x, what do I get?
Negative 5.
Positive 5. I hope it's positive 5. If I put 0 in for y, or p of x,
God, I messed up.
if I take the fourth root of both sides, what does that do? It's plus or minus the fourth root of 1, which is plus or minus
1.
Okay. Last one. Where's the vertex?
Left 5.
Goes down to the right.
To the right.
Right.
When it's in parentheses, it's going to be the opposite. When it's out to the right, or, well, depends. Could be to the left. But. So just go ahead and do that. We could find our intercepts first, but I like to kind of get an idea of what that should be looking like. Wait a minute. That should be turned down, that should be turned down, that should be turned up. Always check and make sure it's turned the right way. Put 0 in for x. What do I get?
55.
And put 0 in for y.
5.
So if that vertex is on the x-axis, you should only get one value when you plug 0 in for y. So we will pretend that 625 is here. And it could be. We change the scale on the y-axis. So far, what we've done is something we already knew how to do, right, before I went over anything in this section. Okay, next. So we have this function. We have to describe the end behavior of the function and then match it to its graph. And I'm just going to draw it over here, and you can look in your book to match it if you want to. So the way I describe the end behavior of a graph is going to be different from how this book does it. So if you follow the book, to me, this book is a little confusing on how to describe that behavior. The way I do it is whether it rises or falls, right? Falls to the left, falls to the right, falls to the, rises to the left, rises to the right. The leading coefficient would be what when you multiply that out? Negative x to the 4th. So this being negative, the leading coefficient being negative, means that it will be, well, wait a minute, let's back up. An even exponent means they're both going in the same direction, right? They're either both going up or they're both going down. And the leading coefficient tells us whether they're going up or down. They're going up or down?
Down.
Down. So the end behavior on both sides of the graph, it's falling to the left and to the right. So the graph falls to the left and to the right. Now, if you, actually, I'm not going to graph this. If you look on page 266, there's only one of the four graphs, one of the six graphs that falls to the left and to the right. And which graph is that? This one? Okay. So that's what they're not asking you yet to figure out what's happening in between. It's just what the end behaviors are. Okay. Next. This is what we're working toward. Learning how to sketch the graph of this polynomial. So what we want to do in order to sketch it, not just find out, we can just look at this to find the beginning and end of behaviors. We don't know where that goes to the x-axis. We can find the zeros, which is what we're going to do to help us find out what's going on in between. I'll tell you what we want to do is set that equal to 0 to find the x-intercept. So 0 is equal to, so we're going to factor this. We need it to be completely factored. We can factor out an x, right? And we're left with x squared plus 2x minus 8. What do I get when I factor that? X plus 4 and x minus 2 multiplies to give me negative 8, adds up to give me positive 2. So to set each factor equal to 0, x is equal to 0, negative 4, and positive 2. You know how I got those, right? Do I need to show how I set each one equal to 0? Okay. So what I'm going to do is, this is where my graph crosses the x-axis. So I'm going to plot points at 0, let's see, let's do negative 2, negative 4, positive 2, positive 4. So at 0, at negative 4, and at positive 2. Now the leading coefficient tells me the behavior of the beginning and the end. Since it's odd, I'm either doing this or this. The leading coefficient is positive, so which one am I doing? This or this? Okay, so it rises to the right and falls to the left, right? Now we have to figure out what's going on in between. And here's where that little chart comes in handy. So let's look back here. Well, first of all, the multiplicity of each factor. The multiplicity would have to do with the exponent that belongs with each factor. This has an exponent of 1. This has an exponent of 1. This has an exponent of 1. They all have an exponent of 1, which means number of times the 0 occurs, each one occurs once, so they pass through. If it was squared, there would be a bounce like a parabola. And if it's cubed, well, squared or even, it would bounce like a parabola. If it's cubed or odd, it would wiggle like the cubic, right? The f of x equals x cubed, how that looks, okay? So depending on the exponent of your factor is what it will be doing at that 0. So all of them are pass-throughs. All of these zeros are pass-throughs. So it's going to pass through and look like that. We don't really know how high that goes up or how far that comes down unless we plug in some points. But we're not worrying with that right now. Okay? So this was a pass-through. This was a pass-through, this was a pass-through. We'll see in the video some more examples if we have time for it. Let's go ahead and do number 36. So you're going to factor out an x cubed. You're left with x squared minus 9. Then that factors x cubed times x plus 3 times x minus 3. According to that chart, and you may have to look back at yours, this would be a pass-through. This would be a pass-through. This would be a, what does the third one do? Right, the odd wiggle. Okay, whatever makes you remember it. So my zeros are x equals 0, negative 3, and positive 3. So I'm going to plot those points. The beginning and end behavior is it this, 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 and this. So are they both going up, both going down, one going up, one going down, and which ones? It's odd, so it's not doing this, it's doing this, or this. Which one?
First.
If it's positive, it's
First
the
one.
same thing, it's similar to the x cubed. So this is going up, this is going down, but now we have to figure out, this one's a little bit different. It's not going to be like the pass-through. So it does pass through here, and it does pass through here, but the 0, it doesn't pass through, it wiggles. So this is kind of hard to, so it does a little curve thing, okay? So it goes, so that's different from this. It has this little curve in here. Remember, it has, and something that can back this up is the n minus 1 terms. So 5 minus 1 is 4. It has 4 terms. 1, 2, 3, 4. 1, 2, 3, 4. 4 terms. I think I have one more here. Yes. And then you'll get your assignments and watch the video if you want to. Factor the polynomial and use the factors, same directions. So how to factor this one? It's a little bit different. How would you factor this one? We don't have a greatest common factor in all 4 terms. What? Yeah, you can put them in the calculator. Yes.
Factor by grouping.
Factor by grouping. So I'm going to group these 2 together and these 2 together. Hopefully when I factor something out, I'll have something in common in both. So let's see. X squared. X plus 3 is left. Factor out a negative 4. X minus,
Plus.
thank you, 3. So when you factor by grouping, you want this to happen. You want what's left here to match up. And it should. So then I can factor out an x plus 3. So this we learned in Algebra 1, but it's probably been a while. Don't forget how to factor by grouping. You take out your x plus 3. This is a term and this is a term. I'm factoring out an x plus 3, which leaves x squared minus 4. Do you remember that? Then I have x plus 3, x plus 2, x minus 2. My zeros are
3.
negative 3, negative 2, and you can put these in order if you want to. Are they pass-throughs, bounces, wiggles? What do they do? All pass through. They all pass through. So I'm going to plot these points. So -3, -2, and +2. What is the beginning and ending behavior? I should have picked some other problems where they have different behaviors. I'm doing this again, right? And they all pass through. And there's my graph. I really don't know how far to go. Oh, wait a minute. Wait a minute. I can find my y-intercept on this one. On the other two, I already had my y-intercept because 0 was my y-intercept. This one, I don't have my y-intercept. So how can I find it? Really quickly.
Replace x with 0.
Yes. My y-intercept is when x is 0, so my y-intercept is -12. So we'll just say that it's right here. Okay. I don't know about you, but do you remember learning how to graph a line? How hard that was? How hard it still is? Isn't this easier? I think it is. You don't? This seems fun. If you like algebra, if you like to factor. I like to factor. Okay, so just very quickly, guys, look here. We didn't talk much about this. If n is the degree of the function, then at most n rules zeros. But that's just something handy to know. You shouldn't have 6 zeros. And what do I mean by zeros again? Where it crosses the y-axis. If it's x to the 5th, you shouldn't have 6 answers. 6 zeros. You should have 5 or less. And then the turning points on the graph whenever you're doing all that is going to be whatever that degree is minus 1, and that's how you can check if you're doing the pass-through, bounce, or wiggle part right, by testing out the terms. Okay? Here's your assignment, and I will put the video on for you to end the lesson. You can work on your assignment while it's on if you want to.